This is Daniel Crawley, Foothills Action Network. We're going to continue our Weather School series with a look at Unit 4, Local and Global Wind Patterns. And once we go through this unit, you will kind of understand how things can impact the weather, not only in a global aspect, but in a local aspect based on terrain, uh, how close you are to water, or other land features. And I think you'll kind of understand after going through this unit the different local and global wind patterns that you can see. Now, first off, what is wind? Wind is air in motion. Wind is produced by the uneven heating of the Earth's surface by the sun. Since the surface is made of various land and water formations, it absorbs the sun's radiation unevenly. One thing you have to remember is that the land heats and cools faster than water. So when you put that in the equation, you're going to have a difference in temperature between one area and another, and that's going to create the motion and the wind. Two factors are necessary to specify wind, that is wind speed and wind direction. So let's look at global winds, and here's a view of the Earth, and you're starting at the equator here at 0 degrees, and you work your way up to the poles at 90 degrees north and south. You have trade winds, westerlies, and easterlies, and we'll kind of go into detail on those. Doldrums. First off, doldrums is an area of calm weather. The trade winds coming from the south and the north meet near the equator. So that's generally where the doldrums are located, is near the equator. These converging or coming together of trade winds produce general upward winds as they are heated. So there are really no steady surface winds. It's just based off heating. So trade winds you get a little bit further away from the equator. Trade winds are just air movements toward the equator. They are warm, steady breezes that blow almost continuously. The Coriolis Effect, and we'll get into that in just a minute, the Coriolis Effect makes the trade winds appear to curve to the west, whether they are traveling to the equator from the north or the south. So the Coriolis Effect, let's look at this for a minute. And the Coriolis Effect is basically the fact that the Earth is spinning, it's turning, okay? Well, as the spin goes on, whatever wind is being created from the heating of the Earth is going to naturally tilt or rotate. So the rotation of the Earth causes an interesting phenomenon on free-moving objects. Objects in the northern hemisphere, which is north of the equator, are deflected to the right, while objects in the southern hemisphere, south of the equator, are deflected to the left. Here's the northern hemisphere, and you see how it turns to the right. And if you're in the southern hemisphere, how it turns to the left. So that's that curve. That's the Coriolis Effect. The Coriolis Effect thus tries to force winds to shift toward the right or left. The Coriolis Effect can at times cause wind to blow up along a pressure gradient. So Coriolis Effect is something you may see at some point as a test question. So the westerly winds, or aka the westerlies, between 30 and 60 degrees latitude, the winds move toward the poles and curve to the east. Here in the northern hemisphere, we are generally in the westerlies. Why did they get that name? It received that name from the direction that the winds generally originate from the west moving to the east. The prevailing westerlies in the northern hemisphere are responsible for many of the weather movements across the United States and Canada. Polar easterlies, you get way up above 60 degrees north in latitude, are where the easterlies start to kick in. So at about 60 degrees latitude, the prevailing westerlies join with the polar easterlies. So if you think about in the west, you've got the winds coming like this, and then the easterlies are coming like this. So they're coming together generally. So the polar easterlies form when the atmosphere over the poles tend to cool. Then the cool air sinks and spreads, kind of like molasses. It's thick. Cold air is thick, and we'll get into that. It's more dense. We'll get into that here a little bit, man, when we talk about local wind aspects. So it just spreads from north and it works its way south using the Coriolis effect. Now, here are some local wind aspects. We don't really have this here in western North Carolina, but if you go to the beach, do you ever notice when you go to the beach it's usually windy? I do. It's pretty enjoyable, actually, especially when it's hot outside. So here's what's happening. It's basically the definition of wind. You've got the land and you've got the water. And we've already said that that heats unevenly. So the fact that it's not heating evenly means that you're going to have wind created. So when you try to heat this water, you've got generally cooler air and it works its way toward the warm air, toward the land. So in the daytime, when you're at the ocean and the sun's heating the sand and heating the ground and it's heating the water, the cooler air from the water is going to try to work its way toward the land. That is called a sea breeze. That is why when you go to the beach during the middle of the day, it's breezy. It's just simple heating of the earth and the creation of wind. Then at night, you basically have the opposite thing happening. What happens is the land starts to cool down quick, and that cold air wants to work its way out to where it's warmer. So that air at the land will work its way toward the ocean. That is a land breeze. Land breezes occur at night. Sea breezes occur during the day. Valley winds. Valley winds is really important in the fact that it's a gentle wind blowing up a valley or mountain slope in the absence of cyclonic or anticyclonic winds. It's caused by the warming of the mountainside and the valley floor by the sun. Now, when I said a few minutes ago that cold air is dense, it means it sinks and it finds its lowest point. So if you think about western North Carolina, you've got a lot of mountains and you have valleys in the mountains. That cold air works its way toward that lowest point where it's more dense. Meanwhile, warm air works its way up. So valley winds, air will rise. Of course, when air rises, it'll form cumulus clouds. So that is the end of Unit 4. We talked about wind patterns that are different both at a local and global level.